Almost all machine learning algorithms can be put into one of two groups, supervised or unsupervised learning. This is based on how the algorithms learn about data to make predictions. Since these concepts are so integral to machine learning, they are very important to understand. As I discussed in the previous module, supervised learning is a method for transforming one dataset into another. For example, if we had a dataset of Monday stock prices, which recorded the price of every stock on every Monday for the past 10 years, and a second dataset of Tuesday stock prices recorded over the same time period, a supervised learning algorithm might try to use one to predict the other. If we successfully trained our supervised machine learning algorithm on 10 years of Mondays and Tuesdays, then we could predict the stock price of any Tuesday in the future given the stock price on the immediately preceding Monday. I encourage you to stop and consider this for a moment. Supervised machine learning is the bread and butter of applied artificial intelligence, also known as narrow AI. It is useful for taking what we do know as input and quickly transforming it into what we want to know. This allows supervised machine learning algorithms to extend human intelligence and capabilities in a seemingly endless number of ways. The majority of work leveraging machine learning results in the training of a supervised classifier of some kind, such as cat or no cat. Even unsupervised learning, which we will learn about more in a second, is occasionally done to aid in the development of an accurate supervised machine learning algorithm. For the rest of this course, we will be creating algorithms that can take input data that is observable, recordable, and by extension, knowable, and transform it into valuable output data that requires logical analysis. This is the power of supervised machine learning. In supervised machine learning, we always give the algorithm the categories or groups. In unsupervised learning, we do not. Unsupervised learning groups your data. It shares a property in common with supervised learning. It transforms one dataset into another. However, the dataset that it transforms into is not previously known or understood. Unlike supervised learning, there is no right answer that we're trying to get the model to duplicate. We just tell an unsupervised algorithm to find patterns in this data and tell me about them. For example, clustering a dataset into groups is a type of unsupervised learning. Clustering transforms your sequence of data points into a sequence of cluster labels. If it learns 10 clusters, it's common for these labels to be the numbers 1 through 10. Each data point will get assigned to a number based on which cluster it's in. Thus, your dataset turns from a bunch of data points into a bunch of labels. Why are the labels numbers? The algorithm doesn't tell us what the clusters are. How could it know? It just says, "Hey scientist, I found some structure. It looks like there are some groups in your data. Here they are." I just said the algorithm turns a bunch of data points into a bunch of labels, but I was not using the word label how it is usually used in machine learning. It would be more accurate to say that the data points have become a bunch of cluster centers. It is up to the data scientist to look at each cluster and determine what label best describes the group. This idea of clustering is something you can reliably hold on to in your mind as the definition of unsupervised learning. Even though there are many forms of unsupervised learning, all forms of unsupervised learning can be viewed as a form of clustering. We will discover more on this later in the course. Check out this example. Even though the algorithm didn't tell us what the clusters are named, can you figure out how it clustered the words? Think about it for a second. Notice that puppies and kittens got labeled as 1 and pizza, hot dog, and burger got labeled as 2. Later, we will unpack how other forms of unsupervised learning are also just a form of clustering and why these clusters are useful for supervised learning. We talked about supervised and unsupervised learning. Next up, I'll discuss the difference between parametric and non parametric learning.